so now let's do some logarithms. So you'll notice when I do these, I'm going to skip the natural logs for the most part, except for the definition of the natural log. And the reason I do that is because if you know your base log properties, you know your natural log properties. But the other way is not necessarily true. So it's good to know both ways. So you'll notice that I'm going to use log base b a lot. So I have log base b of xy is equal, so the log with a base and then the argument being multiplied is actually equal to the log with the same base of each of those arguments, but we can add those two logs together. So you can split your arguments as such. Or you can combine them if you're going this way. These work both ways. Okay? So now if we have similarly the division of our arguments, we can just do the same thing, but we get a subtraction sign. And remember, your numerator is always going to be on the front side of your negative. That's usually how these divisionary changes are going to work. Not just for logs, but for pretty much every other property. Okay, now let's look at if we have log base b of x to the y power, all in the argument. So in this case, what's interesting is this exponent actually just pops out. So we actually end up getting just y logarithm base b of x. Super useful. Okay. Let's go ahead and write the definition of the natural log. So that's log base e of x is equal to natural log of x. So this is just saying these two are the same thing. So every time you see natural log of x, that's what they're talking about, is log base e of x. So ln means log base e. We'll get to why that's important here in about 10 seconds. So we have logarithm base b, and the argument is b to the x. Now, when the argument and the base are the same, they cancel out because the logarithm operator and the exponential operator are inverses of each other. So in this case, your base b and your b cancel out, so you end up just getting x. So let's look back at this one real quick. So if we had e, an argument e to the x, well, that's the same as saying natural log of e to the x, which we all know is just x. This is why it works. Okay, there's only two more things I think we need to know. So we've got b to the log base b of x. And this one is the same as this other one here. So instead of your logarithm canceling out your exponent is canceling out your logarithm. And so in this case, you still just get x. Okay, and the only other thing I want to write out is just your transform. So you have log base b of x equals y, which transforms to b of y equaling x. And that's how you go back and forth between logs and exponents. You just switch these guys around. So you can kind of think of it as like a swap, and then the log goes away, right? Because you notice if this b and this x and the y were there, you just have to swap the x and the y to get them in the right form. Don't know if that's helpful to everybody, but I find it nice to be able to simplify it that way in my head. Okay, let's do a couple examples of these. This is where we can start to get really interesting. So we'll start really easy. So we have e to the negative natural log of 2 equals, now this is what's interesting. I see a lot of people make mistakes here because they're not paying very close attention to the syntax. So let's think back to our exponents, how this works, or we can look here again. So this is saying that the b is canceling out the log base b, so what's inside comes out, but it doesn't say anything about what happens to outside. Let's think about it. Well, this outside is also written as, let's say, e to the negative 1, right, to the natural log of 2. Well, that's a little more familiar. Or maybe we could write this as, maybe it's even more familiar if we write it as this. Maybe we write it as e to the natural log of 2 to the negative 1. And so now looking at it this way, we can clearly see what's about to happen. Well, this e and this natural log of 2 are going to cancel, so we're just going to get 2, but it's still to the power of negative 1. And so then we get 1 over 2. and we just flip that over, right? I see a lot of people make mistakes on that one. Just want to be a little careful. Okay. This next one we're going to do is e to the natural log of 2x times e to the 2x. Should be pretty straightforward. So we have the same base for our exponents, so we can actually add them together. But is that really the best thing we want to do? Because we also have this e to the natural log. Well, I think it makes more sense for us to simplify this e to the natural log than it does to try and add natural log of 2x plus 2x. I don't really know how to deal with that. But I do know how to deal with this. So if we cancel out our e and our natural log, we get 2x, still multiplied, so we have e to the 2x. And in this case, that's as simple as it gets. Can't really do much else there. Okay, let's see. This next example I have, we'll do one of my harder ones here. So we've got e to the natural log of x squared plus 1. Okay, and that's times x to the natural log of e. And all of that is to the power of 1 over natural log of x. Whew. Okay, lots to deal with here. So first thing I think that we should do is I always try and work from my most complicated to least complicated, or where I can simplify the most. In this case, we don't have similar bases, so we can't combine here, which is okay. But I do have this e to the natural log. That's interesting. And then we also have this fractional power here, which is a root of sorts. But we also have exponent rules we can use. So let's use our exponent rules to push this in. Let's do that. Okay, so e, and then we have this multiplied by this, so you get 1 over natural log of x times natural log of x squared plus 1. Okay, and that's multiplied by x, and then 1 over natural log of x times natural log of e. Okay, so we've dealt with the hardest part, that we've distributed that power inwards. Now what should we do? I think it makes sense maybe if we distribute this through, see what happens. Yeah, that'll work. Okay, so what's going to happen here is this e will attack both of these natural logs, but it's only going to push out what's inside in the same form. So this x squared plus 1 is going to come out, divided by x, right? Because this natural log and this e will cancel, and this natural log and this e will cancel. So then we just have over here multiplied by x, and then this natural log of e, we should know that. That's just going to be equal to 1, right? And then natural log of x, 1 over natural log of x. Can't really do much about that right now. Okay. Might have made more sense to keep that natural log of x out. We'll see what happens. Yeah, this one got nasty. We're gonna back up and do that part last and see what happens. Okay, so instead of that, we're just gonna simplify this guy first. We get x squared plus 1, and then we just get that multiplied by x, and then 1 over natural log of x. That makes a lot more sense. Okay, so in this case we get x cubed plus x, and that's to the power of 1 over natural log of x, which can't really do much about, so you could just rewrite it as the power of natural log of x, x cubed plus